Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science, and today we are here with you to continue on thermochemistry, also called energy changes. In this lecture, we are going to solve these questions, and we are going to take our time to use both the thermochemical laws to solve these questions and then the simple approach to also solve this question. So let's begin this question. It says that calculate the standard enthalpy change for the following reactions. Now, given that the standard enthalpies of formation of water and nitrogen dioxide and nitric acid are this value, that value, that value, and that value respectively. Now consider that the value for the oxygen is 0. So this is the reaction. This is the reaction that we are going to find the standard enthalpy of formation. This is the main reaction. Now we are going to use two approaches. Okay, we are going to use two approaches. First, we are going to use the normal change of enthalpy reactions, and then we are going to use the thermochemical laws, okay, to do that. So let's begin this question. So let's begin the solution quickly. Now in the first instance, we're given a reaction which is, as the first one, we're given a reaction to H, that is water in the liquid state, combining with nitrogen dioxide in the gaseous state, and then plus oxygen also in the gaseous state, and forming nitric acid or nitric acid. So forming this nitric acid, and we have that also came as in the form of a liquid, and the moles are 4 and also 4 over here respectively. So the moles are 4 and 4. Okay, so we are going to consider that. Now we said that for the thermochemical laws, we said that the energy of the reactant and the product are always the same. So if you do your subtraction and it is negative, then it is excess. If you do your subtraction and it's positive, then it means that energy has been absorbed, okay, into the reaction. And so for the first one, the total enthalpy for the reactant must be the same as the total enthalpy for the product. If there is a difference, then you will get whether it is endothermic or ectothermic. So we are going to do that. So quickly, we are going to put the formula down and follow the question. So the change of enthalpy for the reaction, the standard enthalpy change for the reaction. So this one, the standard enthalpy change for the reaction is the sum of all the enthalpy of formation of the product, the sum of all the standard enthalpy formation of what? Of all the product, minus the standard enthalpy of formation of all the reactants, So formation of all the reactants. So we are going to get the reactants. So when you subtract all the sum of all the reactants away from the sum of all products, the enthalpy change is the enthalpy change for the reaction. And so we are going to do that. So very simple. And to do that, we have to identify our reactant and then the product. So for the standard enthalpy of the reaction, we have to identify the reactant and the product. So what the reactant we have here is only one reactant that is here. So we have one reactant. So we have one reactant here. We have one product here. So this is a product. And so we are going to take the standard enthalpy. So we are going to take the standard enthalpy of the product, that is the standard enthalpy change of the product. Okay, that is 4 times the value they will give us in the question, and then we will now minus it from what? From the reactant. And the reactant, we have three reactants, and so we have to add all the individual energy of formations. Okay, all the energy of formations, the energy required to form this, form that, form that. And so let's add that. So we are going to get the standard enthalpy of formation of water, and that is 2 moles of water. And so it is very important we write the 2 moles, because energy and quantity are always moving directly. And you also add the enthalpy of formation of what? Of the nitrogen, that is the nitrogen oxide, that is dioxide. And it is 4 moles, and so I have to put the 4 moles here. And then I'll add that of what? Of oxygen, the enthalpy of formation of oxygen gas. So I just have to subtract all the reactants away from all the product, and then the change becomes the value. And so here, let me begin the insertion. Let me begin the insertion here. So the standard enthalpy of the reaction, the standard enthalpy change for the reaction is equal to 1. The value they gave us in the question was that the nitric oxide, for the product, the nitric acid, okay, is this value. This value is the nitric acid, so you should keep in mind that this one is the nitric acid. This one is what we are looking for, because that was the end. Remember, it says that given that the standard enthalpy of formation of water is this, nitrogen dioxide is that, and then this is that. And so we are supposed to do that. But before then, we have to multiply the 4. We have to multiply the 4 times the value given there, which is negative 173 kilojoules per mole. And then we will now also subtract it from the reactant. So let's subtract it from the reactant. The reactant formation of water, it is 2 times the value they give us in the question, and this is the value, which is negative 286. And then we add it to the other reactant, which is also 4 moles, but the specific energy is what? Is positive 33. It's positive 33. Positive 33. And then they said that the value for that of the oxygen is 0. The formation of oxygen is 0. So and of course I told you that for the standard enthalpy of formation of elements in their standard state, like hydrogen gas, which exists at room temperature as gas, oxygen gas, which also exists as room temperature as gas, sodium metal, which exists as solid, and aluminium also exists as solid metal. For all elements, their standard enthalpy of formation is always equal to 0. It's always equal to 0. So that is why they gave us in the question that it is 0. So this is very simple to remember. Okay, good. So let's continue. So when you do your subtraction finally, what we are going to get is that we are going to get the standard enthalpy of reaction for this particular reaction. Yeah, you don't know. It is a formation of this. It's a formation of this. Okay, the standard enthalpy of formation of this particular one. Okay, so let me write that for you. Standard enthalpy of formation of this particular one. Okay, from this particular ones is equal to, when you do your subtraction, we are going to get negative 252 kilojoules per mole. We are going to get negative 52 kilojoules per mole. So that is the value you are going to get. Okay, very, very simple. We are going to get that. Now we can also use what we call the Hess Law. Okay, we are also going to use the Hess Law to solve this, and we are going to get the same value. So we are going to use the Hess Law. That is the second method. Let's use the second method to solve it. Second method. Okay, we are going to use the second method to solve it as method 2. Okay, now in the second method, we all know that we have to use what we call the thermochemical laws. Okay, we have to use the thermochemical laws, and so we have nitric acid that is formed from adding this and this and this. We add a liquid water plus gaseous nitrogen dioxide and gaseous oxygen. We added it and then we got this one. Now we can write the individual energies that led to the formation of each of the reactants. Okay, we can write the individual reactions, okay, based on the energy that led to the formation of each of the reactant and each of the product, and then we do the additions and subtraction using what's called the Hess Law. So let's write the energy that led to the formation of each of the reactants over here. Okay, remember Hess Law is saying that provided the initial state and the final state are the same, the total enthalpy change for a particular reaction is the sum of all the enthalpy change for the stepwise reactions. Okay, so here we are going to divide this into several steps, and then we are going to add all the energy from the process, and then we get the same value. Okay, so here we took this part to achieve it, but we can also add all the individual enthalpies, okay, in the formations of each of them to also arrive at this. So this is what we are going to do. So let's watch here. We are going to divide this into several steps, and the first one we are going to write down the standard enthalpy of formation of water. And we know that standard enthalpy of formation of water begins from hydrogen existing as a gas and then adding it to oxygen also as a gas. And so when you do that, we are going to get water, and we have to be able to balance the equation. We have to be able to balance the equation for the reaction. And so here there are two hydrogens here, one oxygen is here, two oxygens are here. So I need here to be 2, so I'll put 2 here, so that oxygen here become 2, and then here oxygen here become 2. Okay, to do that, hydrogen has jumped to 4, and so I'll put 2 here, so that I can balance the hydrogen also become 4, and then here also become 4, here become 2, here also become 2, the oxygen become 2, and then oxygen here also become 2, because this 2 is in front of this, so it's also 2. So I balance the equation, and then what is happening here, the value that I have here is negative. Let me just write the value. Negative 286. That's the value I have. Okay, so that's the value I have for the formation of water. Now let's write the next one, the nitrogen dioxide. And we know that to form nitrogen dioxide, we need elements such as nitrogen gas, which exists as gas at room temperature. And then I'll add it to oxygen gas, which also exists as that at room temperature. And I have to be able to balance the equation. And so to balance the equation, nitrogen here is 2, nitrogen here is 2, and so I have to put 2 over here to make sure that I balance it. Okay, so to do that, this 2 is here, so I have to put the 2 over here in order to balance the nitrogen, and then that's nitrogen is balanced, but oxygen has jumped to 4, and so I have to put 2 here to balance it. Okay, I have to put 2 here to balance it. So everything is balanced here. We have nitrogen 2 here, and also we have nitrogen 2 here. We have oxygen 2 here. We also have oxygen so we have oxygen 4 here. We also have oxygen 4 here. Okay, oxygen is 4 here. Oxygen is 4 here. Nitrogen is 2. Nitrogen is 2, because this 2 is affecting this one. To get for oxygen is 2 times 2, and so you get oxygen to be 4, and here 2 times 2 is also 4. Then here the enthalpy change for the reaction, we have to be able to write it, which is positive 3. It's positive 3. Remember, it is in kilojoules per mole. Okay, the energies are in kilojoules per mole. So let me write it on top. It is in kilojoules per mole. Then I'll write the formation of oxygen. I also write the formation of oxygen. And oxygen, remember that oxygen is a gas, and to form oxygen from oxygen is always equal to 0. We are forming oxygen from oxygen, so it's 0. And so for that, we are going to get 0 enthalpy. So we have 1 step, 2 steps, 3 steps, and then let's go to the last one. We have what to call this formation of the product. So let's look at, we are also forming the product. So let's quickly form the product. I have H plus here, and then I have this over here. Okay, and so it contains elements like hydrogen, which exists as gas at room temperature, and oxygen also, which also exists as gas at room temperature, and also nitrogen, which also exists as what, gas at what, room temperature, and also contain nitrogen, which also exists as what, gas at room temperature, and we have to be able to balance it. Okay, so here to balance it, we have 2 hydrogens here, so we have to be able to write the 2 over here. Okay, we have to be able to write the 2 over here, so that here is balanced. Nitrogen is also 2 over here, so we also have 2 over here. Let me change the color so that you understand. Let me write it this one. So we have 2 over here. Here is also 2. Hydrogen is 2, nitrogen is 2. Here is also 2. And then oxygen is what? Is how many here? Is 2, but here oxygen has jumped to what? To 6. Oxygen has jumped to 6 over here. Yes, it has jumped to 6. So you have to make here 6. And so to do that, you have to multiply 6 over what? Over 2. You have to multiply 6 over 2. But here, to do that, you have to rewrite the equation. You have to rearrange the equation so that you remove the fraction. So we are going to rearrange the equations to get this one. Multiply these 2 times everything. Okay, so I have this one plus 2 times what? Nitrogen gas, 2 nitrogen gas, and then times 2 times this itself, which is 2 times this, 2 times 6 over 2 is 6. So the denominator is going to be, we are going to move the denominator, and then here we are going to get what? 4. So we are going to get 4. We are going to get 4 over here. Okay, we are going to get 4 over here. So here the enthalpy for the reaction is also the enthalpy for the reaction is negative. Here the enthalpy for the reaction is negative, and so what are we going to have here? Negative 173. Okay, negative 173. So we have 1 reaction, we have 2, we have 3, we have 4. We have 4 reactions. Have you gotten that? Hess Law is saying that it is provided the initial and the final state, provided the initial state, okay, what you began, provided the initial state and the final state are the same, that the same identity of the reactant and the same identity of the product, provided they are the same, then the step you take doesn't matter. Okay, it is independent of the reaction. So all you just have to do is to add all the pieces together, and to put the pieces together you have to use the laws. It said that provided the initial and the final state are the same, so you have to make sure that all the step reactions, you have to rearrange them in such a way that it conforms to the main reaction. And so from here you can see that water is a reactant in this case. Water is a reactant in this case. Water is a reactant. Nitrogen is also a reactant. This is also a reactant. And this are products in this case. So they have to be reversed. So I'm going to get 2. So I'm going to get, this is going to be rearranged. Remember the second law of what? Thermodynamics. Remember the second law of what? Thermochemical laws. It says that the enthalpy, okay, it says that every thermochemical reaction can be reversed provided the sign of the enthalpy is reversed. But however, the magnitude remains the same. And so we are going to reverse this to become what? A reactant, so that it conforms to this. Because here it becomes a product here. So I'm going to reverse it. So I have this over here. I have that over here. And so I have reversed it, and so therefore what happens? I'm going to get this as my what? I'm going to get this plus what? Plus that. And because I have reversed it, okay, because I have reversed it, the sign we are going to get positive 2, 8 what? So we are going to get 2, 8 what? 6, because I have reversed it. And again, because 2 moles of water has been formed, because 2 moles of the water have been formed, I have to multiply the whole thing times 2, because remember I told you that the values that are given in terms of 1 mole. For every standard enthalpy of formation, for standard enthalpy of formation, the values that are given are always given in 1 mole. That is why you always have to balance the equation so that you multiply the mole in front times the specific value they give it to you. Okay, so we will multiply this time this, which is very, very important to do. So we multiply that time that. Okay, very, very important. So then the next one is also to do that. So the next one, what do we have here? We have this is supposed to be a reactant, and here is also a product, so we have to reverse it, and so we are going to get 2. We are going to get 2 what? We are going to get 2N2 being a reactant in this case, and then I have nitrogen gas plus oxygen gas. Okay, and then because I've also reversed it, the value become what? Positive, because here is negative, so here it become what? The value become what? But negative, because I have reversed it, and so positive become negative. We have negative 3, and because 2 moles have been formed, I have to multiply this times what? Times 2. Always check the mole of the compound that is formed. Always check the mole of the compound that is formed. Okay, and make sure that if it is 2 or 3, you multiply times the specific value given the question. And then the next one is for 0, 0, there's no need to change it. Okay, for 0, 0, there's no need to change it. So we are going to get oxygen here is 0. For that, there's no need to change it because the identity is still the same. The identity is still the same. That's for the third one. And then for the final one, you check here nitrogen, or that is nitric acid, is a product in this case. So here is a product. Okay, this is a product, and when you look here, it's also a product. So there's no need to change it. There's no need to change it, but you just have to check the moles. How many moles of the nitric acid was produced? It's 4. So you just have to maintain the same thing. So we are going to maintain the same thing here. Okay, good. So we are going to maintain the same thing quickly. We are going to write whatever we have here is the same. So we are going to write nitrogen gas. Okay, right now I'm not writing the gases because I wrote it in the first case, but you always have to write it. Okay, so I have that, and then what else? Okay, I'm supposed to write the balanced one. Okay, I'm supposed to write the balanced one. Good, so I'm supposed to write this one. So I'm supposed to write the balanced one. So that's what I'm supposed to write. So I'm writing 2 what? H. I'm writing 2A2, and then next I'm writing 2 what? N2, and then I'm writing what? O2. I'm not writing the state because I started writing the state earlier, so we should be able to put that in there. And so I have this one there. So this is still my this is still my product. This is also my product. So we have been able to do that. But again, as we said earlier, because it's 4 moles, we have to multiply 4 times the value. The 4 times the value. The negative sign is not going to change because we have not reversed the equation. We are not going to change it. Have you gotten that? So when you finish, you add everything. And then the energy you get, and then whatever product and then the reactant you get is going to be the same as this particular one, and then the resultant will be also the same as what we did earlier, like this. Okay, remember that this is what we want to get at the end of the day. Our first one, we want to get this one. Okay, so we have to add everything. So let's add it quickly. Now in adding it, we look at it critically. Okay, look at it critically and then add it. So here, what do we have here? You can cancel certain things out before you add, because here we have this one, okay, being a reactant in this case, and here being the product. Okay, so I can take this. Before you add, you have to cancel the reactant and product that are identical. Okay, so those that are identical, after transforming everything, those that are identical, you cancel it. So this and this are the same in terms of mole, in terms of gas, they are the same. So you do that, okay? So good. Before you cancel, okay, always make sure after doing everything, when you still check and you see that there's more, the balance is not working, check your mole, check your what, your ultimate equation, that is the equation that led to the formation of the what, the nitric acid or whatever they asked you to do, and make sure that the moles in front are the same as the moles that you are what, you are adding. Okay, it's very, very important, because when you look here, water here, okay, when you look here, water here had what, 2 moles in front, and after rebalancing it, we also had what, 2 in front here. Okay, we also had 2 in front here. So here we conform to the main equation, which is correct. Then you go to the second one, okay, check whether what you are having here is the same as what you are having there. After balancing your equation, still check whether it is the same as this. So here, when you realize here was 4, and so here was what, 2. So what do? You make sure that what you make here by 2, and so you multiply everything times 2. So times 2 times 2, you multiply here times 2. Good. So here you multiply the front times 2. You also multiply here times 2, and also here times what, times 2, and even the what, this one times 2 again. Okay, so you multiply everything times 2. So you are going to get 4 on top here. You are going to get what? You are going to get 2 what? You are going to get 2 on top here. You are going to get also 2 over here, and then ultimately you are going to get 4 over here, because this will multiply. You are going to get 4. Okay, so now you can now cancel. This will now cancel this one. So this will now cancel this. This will now cancel this, and then we'll have 4 over here. So here we'll have 4 over here. Good. So this and this is 4. Remember that we are going to get 4 at the end of the day. 4 oxygen, okay, at the end of the day. So here we also cancel. You also cancel. Okay, you also cancel. But remember that here we were rewriting this one. Okay, we were rewriting this one. This was what we were rewriting. But I think we escaped the 6, and so 6 must be here. So that when you are canceling, you cancel appropriately. Okay. So here the sum of all the oxygen. So let's add the oxygens here. Okay. So here I have 1 oxygen molecule plus 4 oxygen molecules plus 1 oxygen molecule. So here I'm going to get 6 oxygen molecules overall. So here 1 plus 4 plus what? Plus this one. I'm going to get 6. So this will cancel this, will cancel this, will cancel this. So all this is going to cancel, because when I added the oxygens on this side, okay, of the equation, I had 1 plus 4 of this plus 1 of this, so I'm going to get 6. So this will cancel this, and the remaining oxygen that will be here. So when you add it, so then you add everything. When you add everything, you have to get back your what? Your final equation. So let's add everything and see. Okay, when we add, we are going to get 2. When we add, we are going to get 2 what? Water molecules. That is from here. That is from here, and then we add what? 4. This 4 is here. So we add 4 what? We add 4 over here. Okay. We add 4 over here. Okay, so then we add the 4 over here, and then we add what? This one. Okay, the oxygen. We add the oxygen. Okay. Now and then we add the product. All this has been cancelled. We are left with this one, only this one. So we are going to get 4 what? This. So you see that we've gotten the same thing back again. So that's why the Hess law, okay, doesn't really consider the stepwise reaction, because they will all cancel at the end of the day. Okay. So when you do that, you have to add all the energies along all the stuff. So here the first energy we added was what? So we have to add all the energies. So let's add all the energies. We have to do 2 times positive 286, and then we also have to add a multiply times 4 times the negative 3 this, and then we added the 0. The oxygen 0 is not needed. That is for this one. Oxygen is 0, and then the final one is that we add the 4 times this particular one. Okay, the 4 times negative 173, and then the final answer goes back to what we said earlier. So it is negative 2, 5, 2, okay, kilojoules per mole. Negative 5 to 5 kilojoules per mole. So you can also use the Hess law for this one. Okay, you can also use the Hess law for this one. In our next lecture, we are going to solve this question, but I'm going to use the Hess law first to solve this question before I use the easy one, so that you can better understand it. Thank you.